Alright, so in this section we're going to learn indeterminate forms and also the L-Hospital rule. Okay, so we're going to look at this and also look at this. Okay, before we try, look at the materials. Okay, I'm going to ask some questions, for you. Okay, so these questions may be confusing. What is 0 over infinity, positive infinity? 0. Yes. 0 divided by any non-zero number, we will get 0. Okay. This is positive infinity. Okay. If I don't write a negative sign, that's positive. Okay. Either no positive sign or with a positive sign, that's 0. What is 0 divided by negative infinity? What is this quotient equals to? Still 0, right? Negative infinity is still a non-zero number, and then 0. Sure.
I had a tutor tell me that we can't really treat infinity like a number. Is this just an exception to that, or?
Well, yeah, we cannot treat infinity as a number.
Right.
But 0 divided by a very, very huge thing, infinity, it will give us 0.
Okay.
We're not, yes, here we imagine it is a very huge number, but we don't treat it as a specific number. So they are right. But when we do, calculus,
Okay.
we have to imagine it is a huge number. 0 divided by a huge number give us 0. Okay. All right, then what is this? Well, positive infinity divided by 0. What is this equals to? Infinity. Okay. Well, does not exist. Well, this should be does not exist. Should be does not exist because we cannot put a 0 on the denominator, right? So either you put infinity or you say does not exist. Okay. How about negative infinity divided by 0? Well, here this 0 is, we assume this is it's not a negative. Okay. So it depends on this here. Okay. If, let me put it this way. It is 0, but it is on the positive side. Because this is positive, that positive gives us positive infinity. Negative infinity divided by a positive 0, negative infinity. Okay, so these are helping us to understand when we do some calculations. Okay, you may encounter, oh, I'm having infinity over 0. What is this? Oh, I'm having a negative infinity divided by 0. What is that? You may write your answers like this. Okay? Okay, so these are not the indeterminate forms we're talking about. No. These are just the special cases involving infinity and 0. Okay? Now, we're going to look at indeterminate forms of the types. Okay? I'm going to ask a volunteer to read just these two definitions for us. Who want to read? Tanner?
In general, if we have a limit of form limited f of x divided by g prime, where both f of x goes to 0 and g of x goes to 0 as x goes to a, then this limit may or may not exist in this called an indeterminate form of type 0 divided by 0. In general, if we have a limit of form f of x divided by g of x, where both f of x goes to infinity or negative infinity and g of x goes to infinity or negative infinity as x goes to a, then this limit may or may not exist in this called an indeterminate form type of infinity divided by infinity.
Very good, thanks. Okay, so that's why just now I use some special case. Okay, yeah, for involving 0 and infinity, we know, oh, this is we can get 0 for sure, and these we don't know it's infinity. However, sometimes when we are going to find limits, oh, when x goes to a, we find, oh, both of the numerator and denominator of this function goes to 0. So we're going to have what? A 0 over 0 indeterminate form. So when we have 0 over 0, what conclusion can we get? Can we say 0 over 0 equals 0 or 0 over 0 equals infinity? Can we say no? Okay, see? 0 over 0 type of infinity. We don't know whether the limit exists or not. Okay, but we call this type of the limit is called in the form of 0 over 0, or in the type of 0 over 0 indeterminate form. okay? Because if we encounter limit looks like this, we don't know whether the limit, what's the result of the limit. So we have to, further study it, okay? So that's why later we will look at the L-Hospital rule, okay? Similarly, if both of the top and the bottom functions goes to infinity, okay, maybe past infinity or maybe negative infinity, so we'll have what? We will have a type of the limit with what? Infinity over infinity. Can we say the limit of this limit exists or not? We don't know, okay? It's not like zero. What is that? It's infinity over infinity, okay? So we don't know. This type of the limit we call is in the indeterminate form, okay, of type infinity over infinity. So we don't know whether limit exists or not. Well, the thing is, are we able to solve for this type of limits questions? Yes, we do. So if we encounter 0 over 0 type or infinity over 0 infinity type, okay, we're able to at least compute this limit further by using the L-Hospital rule, okay? I'm going to ask another volunteer to read this rule for us. Who want to read? Dave?
Suppose f and g are differentiable and g of x is not equal, g prime of x is not equal to 0. When an open interval I that contains a except possibly at a, suppose that the limit of f of x as x approaches a is equal to 0 and the limit of g of x as x approaches a is equal to 0, or that the limit of f of x as x approaches a is equal to positive or negative infinity and the limit of g of x as x approaches a is equal to positive or negative infinity. In other words, we have an indeterminate form of type 0 over 0 or infinity over infinity. Then the limit of f of x as x approaches a is equal to the limit of f prime of x as over g prime of x as x approaches a if the limit on the right side exists or is infinity or negative infinity.
Very good. Thank you so much. Alright, so what is L-Hospital rules telling us? When we check, okay, both f and g goes to 0 at the same time, or both of them goes to infinity at the same time. So we'll have determinate forms of this or that. Then how to find the limit, guys? What do? We're going to differentiate both top and the bottom, so we can have f prime of x and g prime of x, and we see whether we're able to find the limit of this quotient. See?
So you have to use a quotient.
This is not a quotient rule. This is we differentiate both top and the bottom, and then we get a new expression and see whether we can simplify this expression to make the limit exist. Okay, so I will use some example to show you. Okay, so we're gonna, find the limits, use L-Hospital rule if appropriate. Okay, so when can we use L-Hospital rule so far? Only when we encounter 0 over 0 or infinite over infinite type, okay? If we encounter what? These types directly, are we able to use L-Hospital rule? No. No. And then when we encounter this type of the limits, we already know how the results, right? 0 divided by any infinity equals 0. Infinity divided by 0 depends on whether the given 0 is positive or negative, and then the given infinity is positive or negative. We can get what? Either infinity or negative infinity and so on. Only when we encounter this type or that type, we are able to use L-Hospital rule, okay? So now we have 6 questions, A, B, C, D, E, 5 questions, okay? I'm going to show you some questions, okay, so we can try, okay? We can try. Okay. So I will say that we can do the question B and C at least, okay? B and C, okay? And also I will show you more on the next page, okay? So let's try these 2 questions. Find the limit of ln x over square root of x. Let's check the f and g. When x goes to infinity, how about ln of x? What is the graph for ln of x? Natural Laplacian function. When x goes to infinity, ln x goes to what? Infinity, right? When x goes to infinity, how about square root of x? Also goes to infinity, right? So, what is this form? what type of this form it is? Infinity over infinity. So yes, it is an infinity over infinity type. Now we're able to use what? L'Hospital rule to keep on finding the limit, okay? So the limit will be still x goes to infinity. What do you do to deal with f and g now? Differentiate both of them at the same time. Ln x derivative is what? What is derivative of Ln x? 1 over x. What is derivative of square root of x?
X is the negative 1.
Let me see. Oh yes, you're right. It's going to be 1 over, you're right, 1 over square root of 2 times square root of x, right? So now we're having this. This looks like still complicated. Can we simplify it? Let's simplify it. Limit x goes to infinity. 1 over x divided by 1 over this is equivalent to times by 2 times square root of x over 1. Right? So we can rewrite this as 2 times square root of x divided by what? X. You guys? Right? And then because when x goes to infinity, x cannot be 0, right? So square root of x and x, can we cancel out the square root of x from both top and the bottom? We want to make sure this thing is as simple as possible. So I would say that divide by the square root of x from both top and the bottom, it will give us 2 over square root of x. You agree with that?
I don't understand why. Why can't you just restrict the domain in the answer?
What do you mean? The district?
Restrict the domain, just say the domain is 0 to infinity, because you can't have a negative 1.
The domain is 0 to infinity. Yeah. For Ln x, the domain is 0, right? But we cannot include 0.
Right.
So that means we are able to divide by square root of x because x cannot be 0. Well, here, Sammy, we're not talking about when x is close to 0. Even if Ln x, domain is from 0 to infinity, for this minute, we only talk about when x goes to infinity. See? We don't have to worry about when x is close to 0 or something like that. It's not we're talking about on the entire domain. We're talking about only when x goes to infinity. What of this function 2 over square root of x over x will goes to what, right? That's the idea for a limit. This limit means when x goes to infinity, what is the 2 square root of x over x will goes to, right? Okay, so because x cannot be 0 because x goes to past infinity, so we can divide by the common factor square root of x from both top and bottom. Now, on the top we have a constant. On the bottom we have a square root of x. When x goes to infinity, what do you think about this thing? When x goes to infinity, yeah, a constant divided by infinity give us what? 0. You're right. So see, previously we don't know, but by using the L'Hospital rule, we differentiate both top and bottom, and we simplify it until we can get an answer. Sometimes when we simplify it, we still have what? 0 over 0 infinity over infinity. What do? Use L'Hospital rule again. Okay, I'll show you some examples. We have to do it many times. Okay, many times, because every time we simplify, we have a 0 over 0. Or infinite over infinite. Then we use L'Hospital rule. We simplify. Then we still have 0 over 0 or infinite over infinite. We still have to keep on do that. Okay. So this is a question B. Do you want to try a question C? They look very similar, but they are different, guys. Careful. This is Ln x over square root of x. This is Ln x over x. And this is when x goes to infinity. This is when x goes to 0 positive. They're totally different questions. Looks very similar, but they're different. Give it a try, please. And you have to know, only when we have the 0 over 0, infinite over infinite type, then we can use L-Hospital rule. Sometimes if we don't have those two types, we're not able to use those.
So how can we use L-Hospital?
Sometimes we may not be able to use L-Hospital rule. No, we can. Sometimes we cannot. Okay. So see, Brian has this concern. Okay, when x goes to 0 positive, what is it? Ln x goes to negative infinity, right? See, when x goes to 0 from the positive, and then Lx goes to negative infinity, right? How about when x goes to 0 infinity, 0 positive? 0 positive. So what is this? Negative infinity divided by 0 positive. So what will we have? See, that's why we have these special cases at the beginning of the class. What is infinity divided by 0 positive? 0 positive is positive. Negative infinity divided by a positive number gives us a negative number, and then it's going to be what? Negative infinity. Okay. So if this is a indeterminate type, no. So we're not able to use L-Hospital rule. Answer is negative infinity. Done.
I'm just sorry. I'm still a tiny bit confused. I thought that the ln the domain of ln of ln x doesn't include 0. So how does it end up being negative infinity? I'm sorry.
Because ln x, the graph looks like this, right?
Right. It runs away to an asymptote at 0.
Yeah.
And runs away forever.
Yeah. And then this limit talks about when x goes to 0 positive. So these x, when they goes to 0 from, say this is 0, right? When they goes to 0 from the right, when they goes to 0 from the right, all of these x are in the domain for ln x. So those x are valid x.
Okay.
But we're not talking about when x is on this entire domain. We only talk about when x goes to 0.
It's very, very close to 0.
Close to 0, we know the Lx will goes to negative infinity.
Thank you. Sorry.
No problem. So that's good for these two questions. See, one is able to use L-Hospital rule, the other one's not. I put a LH here, so it says, from here to here, why we get this step? L-Hospital rule. But this one, we're not even started. Done. Negative infinity. You want to try more practice questions? Yep. So, let's do C, D, and E, okay? D and E, okay, I will give you time to practice this, and also plus the first question A, okay, I will give you time to practice. And then how about I'm going to introduce the other indeterminate limit types, okay? Then I'll show you examples, and then I'll give you time to practice, okay? Alright, so we learned about 0 over 0, infinite over infinity. Sometimes we may not have 0 over 0 or infinity over infinity directly. We may have indeterminate products. And how can we deal with that kind of the questions, okay? So I'm going to ask volunteer to read the indeterminate products. This is something that I need you to master as well. Grant, please.
Indeterminate products. If the limit of f of x as x approaches a equals 0, and the limit of g of x as x approaches a is infinity, or negative infinity, then it isn't clear what the value of limit x as limit of f of x times g of x as x approaches a. This kind of limit is called an indeterminate form of type 0 times infinity. We can deal with it by writing the product fg as a quotient. Fg equals f over 1 over g, or fg equals g over 1 over f. For example, the limit of x, x, the natural logarithm of x, as x approaches positive 0.
Okay, very good. Thank you. Okay, so in this class, I'm going to test you 3 types for L-Hospital rule. 0 over 0, infinity over infinity. And the third type is what? In indeterminate products, okay? What kind of, limits is called of indeterminate products, this form? If one of the function, if we have a product, one of the function goes to what? 0. The other of the function goes to either positive infinity or negative infinity, okay? One of these two functions, one goes to 0, the other goes to infinity, or negative infinity. Then what do you think about the product? What is 0 times by infinity? We don't,
Well, this is pretty,
0 times by a fixed number give us 0. But infinity, we don't know which one is more stronger, right? 0, you say 0 is more stronger, you get 0. I would say infinity is like so huge, we don't know, okay? So, this type we call it what? It is what? 0 times by infinite time. This is the third type I'm going to test you in Calc 1, okay? And then when we encounter this 0 times by infinite type, how can we solve for that kind of the limit? Say for example, guys, when we need to compute limit of x times by ln x, let's check this product. When x goes to 0 positive, what about x? X goes to where? 0. When x goes to 0 positive, what is ln x goes to?
Negative infinity.
So we have a 0 times by infinity, form this time. And how do we deal with this type of a limit? We don't know whether the limit exists or not. We don't know which one is stronger, 0 or infinity, we don't know. So, it is very important for us to rewrite the product as what? The product is f times g, right? We write it as what? Either f over 1 over g, or g over 1 over f.
which one you use, it doesn't matter.
Doesn't matter. Depends, okay? We want to rewrite this product such that we can have what? 0 over 0 or infinity over infinity. Okay? So still, we encounter the product form. We have to convert it to what? 0 over 0 or infinity over infinity. Then we can use what? L'Hospital rule. So let me give you one example from this example. This is 0 times by infinity, right? So how can we solve this limit? What do we do?
Place, if you like, 0 on top.
Yeah. Either we have two functions, x and ln x. Keep one function on the top, and then keep one function on the top, no change. And then do a reciprocal of the other function. Okay, so which one do you want to keep on top? You can choose x, or you can choose what? 1 over ln. Why? Because x divided by 1 over ln x will give us this, right? But, see, this will be what? If we do it this way, we'll have a 0 over what? 0, see? This is 0, 1 over ln x will go to what? 0. Then we can use L'Hospital rule. But do you want to keep the x on the top and the ln x on 1 over ln x on the bottom? What is derivative for 1 over ln x? It's too hard. We have used quotient and too much, okay? So for this question, we're going to keep the ln x on the top, and then we do what? The reciprocal of x, which is 1 over x on the bottom. Guys, do you see that? Now we're having what? Infinity over what? What is 1 over 0? Infinity over infinity type. Well, here, ln x give us negative infinity. This is 1 over positive 0 give us what? Infinity. So this is infinity over infinity. Now we can use what? L'Hospital rule, okay? So by using the L'Hospital rule, let's differentiate ln x. What do we get? Right? What is the derivative of 1 over x? Negative 1, x to the negative 2, give us what? Negative 1 over x squared. So I want you guys to memorize 1 over x derivative equals negative 1 over x squared in the future, okay?
Is that on the test?
Well, you can write it down on your test, on a formula sheet. if you cannot memorize this. The derivative of 1 over x equals negative 1 over x squared. Write it on the formula sheet. Or every time you have to do it. So would everybody differentiate both top and the bottom? Right? Now what do we do from here? Simplify. This is negative, okay? Simplify. Limit x goes to 0 positive. 1 over x divided by negative 1 over x squared is the equivalent to what? Multiplied by negative x squared over 1, right? And let's see what we can simplify that to be. So this x and this x cancel out, right? Because x goes to 0 positive, x does not equal 0. So we should have what? Negative x. Well, so when x goes to 0, we'll have a negative 0. What is it? 0. Done. You guys, that's good? So that means when we encounter a 0 times infinity, we make sure one function keeps on the top, and then we do what? Reciprocal of the other function on the bottom, and make sure it's either 0 over 0 or infinity over infinity, and we keep on using L-Hospital. You guys, that's good? And then these two examples, okay, see, let's check, okay? When x goes to infinity, x times by sin of pi over x. So this x goes to infinity, right? How about when x goes to infinity, sin of pi over x? X goes to infinity, pi over infinity is what? 0, right? The sin of 0 is what? 0. So we have infinity over times by 0, right? You are going to decide, you're going to put which function on the top. Usually, we put the function which is easier to calculate, harder to find a derivative. We put it on the top. You see? Compare x with ln(x). ln(x) is harder to get a derivative, right? So we put the ln(x) on the top. We leave the easier one, we flip on the bottom. So this one, x times the sin of pi over x, which function do you want to keep it on the top? Same. You want to flip the x on the bottom, okay? Give it a try later, okay? I'll give you time. This one, let's check. X to the cube goes to infinity. Negative x squared, negative infinity, right? What is e to the negative infinity? Do you remember the graph for exponential function? Well, when this part goes to negative infinity, e to the negative infinity goes to what? 0. So this is also infinity times by 0 form, okay? So you know which one to put on the top and the bottom, but because this is a negative exponent, if we put this thing, the reciprocal of this thing on the bottom, it may give us what? A positive e to the x squared. So it really depends, okay? It depends. So this question, the hint is, keep the x cube on the top, and then flip this on the bottom, okay? All right, so these questions are over what? 0 times by infinity, okay? You can also see the indeterminate differences, okay? So this is an infinity minus infinity. We have to simplify it until we can use 0 over 0, infinity over infinity. But I'm not going to teach you anything from this type of the, indeterminate forms. So I would say we can cross that out, okay? You can only concentrate yourself on the 3 types. What are the 3 types? Let's kind of summarize. 0 over 0, infinity over infinity, 0 times infinity. When you have 0 times infinity, what do? Okay, one function on the top, and then put what? The other function is reciprocal on the bottom. And keep using what? L-Hospital rule. You guys, that's good? So this is the idea for section 4.4. Are we good?